Lights! Camera!
Action! We did a one-sample t-test for means.
The problem that we chose was in the textbook on page 589, problem 80. The problem reads as follows. Bottles of a popular cola are supposed to contain 300 milliliters of cola. There is some variation from bottle to bottle because the filling machinery is not perfectly precise. From experience, the distribution of the contents is approximately normal. An inspector measures the contents of 6 randomly selected bottles from a single day's production. The results are 299.4, 297.7, 301.0, 298.9, 300.2, and 297.0. Do these data provide convincing evidence that the mean amount of cola in all the bottles filled that day differs from the target value of 300 milliliters? Carry out an appropriate test to support your answer. The first step of our one-sample t-test for means is the state. Our state for this problem is, we want to determine if the mean amount of cola in all the bottles filled that day differs from the target value of 300 milliliters. Now, in the state, you also need to state the null and alternate hypothesis, and then define any variables that are used. For the null hypothesis, use h sub 0 colon mu is equal to 300. For a null hypothesis, something always has to be equal to something else. Then, for the alternate hypothesis, use h sub a colon mu is not equal to 300. For an alternate hypothesis, the variable can be greater than, less than, or not equal to something else. For our particular problem, we want to find if the mean amount of cola in all bottles that day differs from the target value of 300 milliliters. Not is greater than or less than 300 milliliters. So that is where we get our alternate hypothesis of mu is not equal to 300. The last part of the state is to define any variables that were used. For our specific problem, we define the symbol mu as the mean amount of cola in cola bottles filled that specific day.
After the state, the next step is the plan. The first thing you do in the planning step is state the type of test that you are doing. In this problem, we are doing a one-sample t-test for means. After you write this, you have to state the conditions of the problem, which is normality, randomness, and independence. Normally, to test normality for a means problem, the central limit theorem would have to apply, which is n is greater than 30. Or, the box plot of the data must show no skewness, therefore proving normality. For this specific problem, the population of cola bottles is approximately normal, therefore the sampling distribution of cola bottles is approximately normal. The next condition is randomness. In order to continue, the sample has to be a simple random sample from a large population. Our problem was an SRS of all cola bottles. The last step of the plan is to make sure the sampling distribution is independent. It is independent if the sampling distribution is at least 10% of the population. So we can assume that the sampling distribution of cola bottles is at least 10% of the total population of cola bottles, meaning that the total population of cola bottles is greater than 60. The third part of the 4-step hypothesis test is the do. The do consists of all the calculations of the problem. Before performing the test, one must enter the data into their calculator. In order to do this, press the Stat button on the calculator, then hit Enter. Then list the 6 numbers individually into L1 of the calculator. This is what your calculator should look like at this point. Now that our data is in a list, we can start a test. For this specific problem, we are doing a one-sample t-test for means. To get to this test on the calculator, press the Stat button, then use the arrow key to move over to Tests, then press number 2, which is the t-test on the calculator. This is what the calculator screen should look like. Since the data is in a list, make sure the word data is highlighted on the calculator. Use the arrow key once to bring you down to mu sub 0. Type in the number 300 since cola bottles should contain 300 milliliters of cola.
Then use the arrow key again to bring you down to list. Then hit the second button and then hit the 1 button. This makes it list 1. Then use the arrow key down twice. This is where you select mu is not equal to. It's the one that is an equal sign with a slash through it. So your calculator should look like this at this point. Now hit calculate. These are all of your values that you should write down and label in the do part of the one sample t-test. Okay, now. Labeling is key in the do section of the hypothesis test. So here we have n, which is the sample size, is equal to 6. Degrees of freedom, or n minus 1, is equal to 5. Our t statistic is negative 1.576. We have our x bar is 299.03. Then we have our s of x, which is 1.503. And then we have our p-value, which is 0.176. And lastly, which a lot of people always forget to label, but is very important in the do section, is alpha, which is 0.05. The last part of the do is drawing the curve. So, hit Stats, Test, number 2, then scroll down and over to hit Draw. This is what the normal distribution curve should look like. And then this one. So overall, including the curve, this is what the do section of your hypothesis test should look like. The last part of the 4-step hypothesis test is the conclude. The conclusion is a 2-sentence wrap-up to the entire problem. The first sentence of the conclusion refers to the null hypothesis, while the second sentence refers to the alternate hypothesis. In general, if your p-value is less than alpha, you reject the null hypothesis in favor of the alternate. If your p-value is greater than alpha, you fail to reject the null hypothesis. Now, for our specific problem, our conclusion is, due to the fact that our p-value, which is 0.176, is greater than alpha, which is 0.05, we fail to reject the null hypothesis. We do not have enough evidence to conclude that the mean amount of cola in cola bottles differs from the target value of 300 milliliters. Now, if our p-value was less than alpha, we could conclude that we do have enough evidence that the mean amount of cola in cola bottles differs from the target value of 300 milliliters. But since that our p-value is greater than alpha, our conclusion decides that we do not have enough evidence to conclude that the mean amount of cola in cola bottles differs from the target value of 300 milliliters.